The next couple videos will walk you through different types of calculations we can do, all using this mole concept. In this video, we'll look at a calculation where we convert moles to atoms. If I had 2.5 moles of chromium atoms, how many individual atoms would that be? Way back in September, we were doing some unit converting, and we were using a proportion method, where maybe we had like grams and we were switching it to pounds, or we had quarts and pints, and a mixture of English units and metric units, where I couldn't just move the decimal spot to make the unit conversion. That proportion method is what we're going to use to solve these types of unit conversions too. So back in the day, like in September, it's all about the method. We're really not going to use like pounds and ounces in chemistry, but it's that method of setting up a proportion to do a unit conversion that we will use. So here's how we start these. With what you're given, 2.5, the abbreviation for mole is just MOL. That's moles of chromium. I want to set up a proportion so I can do this unit conversion. The unit that you want to cancel goes on the bottom. I want to cancel moles of chromium. The unit that you want goes on top. We want to switch this to atoms of chromium. I always set up my proportion first with the units because now I know where to put the numerical values. The relationship between atoms and moles, there are 6.02 times 10 to the 23rd atoms in 1 mole of chromium. And I'm kind of a freak about my units canceling. And so when I see this, I have moles on top, moles on bottom. They cancel. And the only unit that I have left is the unit that I want, atoms of chromium. When that value is on the top of the proportion, we multiply across. If it were on the bottom, I would divide. So to solve this, in my calculator, I'm going to put 2.5 times 6.02 times 10 to the 23rd. Now, as far as significant figures, this is going to be a good thing. We're multiplying, so we're going to round our final answer to the piece of data that had the least amount of sig figs. However, this number here, the 6.02 times 10 to the 23rd, it's considered a constant. So to really get your sig figs, we're just going to go back to the amount of figures in the original number given. So if the original number, 2.5, if that has 2 sig figs, we're just going to round our final answer to 2. So I'm going to call this 1.5 times 10 to the 24th atoms. Let's get that right off my calculator. Now some of this makes sense. Every 1 mole is 6.02 times 10 to the 23rd atoms. I have 2.5 moles. It makes sense that you multiply. Oh yeah, that's not so bad. I get that. So yeah, it would be like about 15 times 10 to the 23rd moles, atoms, or 1.5 times 10 to the 24th atoms. It's all about setting up these proportions and canceling your units. Let's try this next one. I have 0.26 moles of argon, and I want to do a unit conversion. I don't want moles of argon. I want atoms of argon. The unit that I want goes on top. The unit that you want to cancel goes on the bottom. Then I just put my relationship between atoms and moles in the proportion. There are 6.02 times 10 to the 23rd atoms in 1 mole. I can cancel moles on top with moles on bottom. and I just multiply this across. So in my calculator, I say 0.26 times 6.02 times 10 to the 23rd power. My original number has 2 sig figs, just the 2 and the 6. The 0 is a placeholder, so I'm just going to leave 2. 1.6 times 10 to the 23rd atoms of argon. Not bad, huh? And again, you can kind of make some estimates. Does this answer seem reasonable? Yeah. It should be a little bit less than 1/3 of a mole. 1/3 of a mole would be 2 times 10 to the 23rd. I have a little bit less. I don't have 0.3 moles. I have 0.26. 0.333 repeating. I have a little bit less than 1/3. So yeah, my moles, it should be a little bit less than 2 times 10 to the 23rd. It makes total sense. Now you can also do this with compounds, and it's not like it gets any harder. I start with what I have, 1.04 moles of methane. Now if you get an organic compound, you might need to sketch it. Meth is the prefix for 1 carbon. ANE means all single bonds. So this should be a carbon with 4 single bonded hydrogen. My formula is CH4. Now we set up our proportion. We do not want moles. We want molecules. And you can put CH4, or you can just put the unit in. On the line, I put the relationship between molecules and moles. And what do you know? They're all the same. 6.02 times 10 to the 23rd particles in 1 mole of anything. Moles and moles cancel. And I am doing the exact same thing for all of these calculations. The particle could be an individual atom, like chromium and argon. They're elements, so their particles are atoms. Methane is a compound, so the individual particles are called molecules. You could have 1.04 moles of anything, and you'd multiply by 6.02 times 10 to the 23rd to figure out how many individual particles you have. You could have a mole of chickens, you could have a mole of turkeys. That's a lot of chickens and turkeys. But you do the exact same kind of calculation. I'm going to multiply across, and this time I have 3 sig figs in my original. 3. So I'm going to leave 3 in my answer. I'm going to say 6.26 times 10 to the 23rd molecules. And again, I can see if this answer makes sense. I have just a little bit more than 1 mole. Oh yeah, I have a little more than 6.02 times 10 to the 23rd. 6.26 times 10 to the 23rd particles. Notice on all of these, we didn't do anything different when they changed the identity of the particle. Chromium, argon, methane. It was the exact same proportion every time. The identity of the particle was irrelevant. I didn't even need to write the formula of methane, because we're comparing amounts of particles per mole. 1 mole of anything has 6.02 times 10 to the 23rd particles. So now there are 2 more. There's number 4 and number 5. So what I might suggest at this point, pause the video and give them a shot. Try 4 and 5, then bring it back and check your answers. See if you're really catching on and getting these little calculations correct. Alright, so let's see what we got here. Let's see if we're doing this right. Copper to nitrate. Copper is +2, nitrate is -1. So So I did write the formula, but in reality, I don't really need it. I need to know how many moles I have. 0.003 moles of particles, whatever that particle might be. And then I set up my proportion. I want to cancel the unit that I started with, moles, and switch it to molecules. There should be 6.02 times 10 to the 23rd molecules in 1 mole of anything. My units should cancel, moles and moles. And again, I just multiply across. Now here, the original number only has 1 sig fig. Just the 3. All those leading zeros are placeholders. So I just rounded it to 2 times 10 to the 21st. Multiply across, I just left 1 sig fig. You can go back to the number of sig figs in the original given number. And so even with number 5, lithium oxide, cool. I don't need the formula, I wrote it. It's kind of irrelevant, because if I had 0.73 moles of anything, it would be 4.4 times 10 to the 23rd particles. That could be moles of donuts, it could be moles of molecules, atoms, anything. I would do the exact same setup. Moles should go on the bottom so that they cancel, and then I multiply across, leaving 2 sig figs. The original number, 0.73, has 2 sig figs, so I left 2. Now, one thing to make note of, on your calculator, you might see this number written as 4.4 E23. So we have to get used to calculator lingo here. That is your calculator's way of showing scientific notation. That is not a correct measurement, or it's not the correct numerical value. That E is calculator language. So we want to make sure that we report this. 4.4 times 10 to the 23rd. That's the way we need to report our final answer. Not 4.4 E23. What does E mean? Times 10 to the 23rd power. This little E means times 10 to the what? And the number after the E, that's the exponent. So it's your calculator's way of showing scientific notation. We want to write our final answer in scientific notation. Which reminds me then, if you want to use your calculator to input some of this scientific notation, you have a few options. The best option is to use your exponent key. So I would type 6.02, and then you have a key, it's like an EE key on your calculator. That key is specifically meant to be used for scientific notation. It means times 10 to the what? Times 10 to the what? So you just hit on your calculator 6.02. Hit the EE key, and then all you have to do is say 23. Then you just tell your calculator what the exponent is. That is your calculator's way of doing scientific notation. At least most calculators. This is good. Yay. I like it. I think it leads to the least amount of errors. Here's the one that I do not like. Don't do this. Sad face. 6.02 times 10. Then they hit the EE key. 23. Your final answer will be off by a power of 10. So if you did that on this last calculation, you would get 4.4 times 10 to the 24th. Because you put this extra times 10 in there. You don't need that. When you hit that EE exponent key, your calculator knows scientific notation. Times 10 to the, you just tell your calculator the exponent. You do not need to say times 10 EE23. And I think sometimes people get that confused with this one. This one I'll say is like, okay. It's okay. They're obsessed with that caret key. 6.02 times 10. Then they'll hit the caret key. 23. It's okay. It will work in some situations, but there are a few times when it might not work. So that's why I'm a little leery of this one. If you're not sure if this is going to work, you can always put it in parentheses. The times when this doesn't work is if you might have a whole bunch of other calculations to do, and your calculator might not do order of operations the way that you want it to. So if you're obsessed with your caret key, just put that quantity in parentheses so that your calculator knows that that is one specific quantity. Then you might be okay. But I would say make friends with that EE exponent key. You're going to use it a lot. And these calculations really then should be pretty straightforward.